abstract data nodes sparking to life and connecting in rapid, unpredictable patterns. We are well past the days of the simple chatbot. Today, modern enterprises deploy highly complex, fully autonomous AI systems. These AI agents are built to take action. They constantly assess their environment and make independent decisions in real time, often operating within highly regulated and high-risk environments. But the standard IT toolkit is blind to how these decisions happen. The traditional metrics, logs, and traces we use to monitor application health can tell you if a server is online, but they cannot explain an AI's internal chain of thought. Building powerful, autonomous minds with no way to audit what they are thinking creates a massive, invisible attack surface. We are effectively flying blind. Because of this complexity, the enterprise threat landscape has fractured into two simultaneous fronts. Attackers are targeting both the AI's abstract logic and the physical, bare metal server it runs on. Focusing on just one leaves the entire system exposed. A perfectly secured AI model is compromised the moment its underlying hardware is breached, and an ironclad server offers zero protection if the software logic itself has been poisoned. To survive, organizations need a synchronized defense strategy. They have to lock down the physical silicon and the cognitive software at the exact same time. Security has to start at the foundational layer of the cloud computing stack, where physical hardware dictates the rules of the system. This motherboard schematic highlights an isolated chip called the Baseboard Management Controller, or BMC. It acts as an independent microcontroller that governs hardware health, fan speeds, and power states. Notice how it operates entirely separate from the main CPU and the operating system. Because the BMC functions beneath the operating system, it represents a critical vulnerability. If an attacker hijacks this component, they can bypass the OS firewalls entirely. They gain total, undetectable control over the entire system. Securing this layer requires strict, hardware-level defenses. Integrating trusted platform modules and digital boot guards verifies the firmware's integrity before the system even loads, severing any unauthorized connections. Technologies like Azure Confidential Computing enclaves protect the system further, encrypting data in use directly at the processor level. Without establishing this silicon-level root of trust, no software security built on top of the server can be fully trusted. Once the bare metal hardware is secure, the defensive focus has to shift up the stack to the AI's cognitive pipeline. In this representation, we see how adversaries attack an AI model during its infancy. Through data poisoning, they inject targeted biases and backdoors into the training corpus, slowly infecting the system before it is even deployed. At runtime, the tactics change. Attackers exploit the live model using prompt injections or complex jailbreaks, intentionally overriding safety filters to exfiltrate private data or force unbounded API calls. These cognitive attacks easily bypass standard network security. They work because the malicious instructions are perfectly disguised as normal, authorized user input. A secure server means very little if the AI's reasoning can be externally manipulated to hand over sensitive information. To track this internal decision-making, organizations use a framework called Agentic observability. This structural matrix outlines the 4 pillars required to pierce the AI's black box. First are perception and reasoning. This tracks exactly what raw data the agent received from its environment and exposes the internal, step-by-step logical planning it used to process that information. Next are choice and governance. This audits why the agent selected a specific action over the other available alternatives, and verifies that the final decision strictly adhered to predefined ethical rules and safety guardrails. Enforcing this requires strict data provenance. Tools like Microsoft Purview track data lineage and classify sensitive fields long before that information ever reaches the model's perception layer. Cognitive observability is the mechanism that takes unpredictable, autonomous AI behavior and transforms it into auditable, verifiable enterprise actions. Securing the enterprise requires a single, cohesive zero-trust architecture. This full-stack visualization connects the lockdown hardware directly to the monitored agentic AI. The system continuously verifies integrity across the environment, scanning from the deepest silicon circuitry up through the model's logical reasoning. The methods adversaries use to breach systems have moved far past traditional perimeter attacks. Relying solely on edge firewalls, leaves the internal logic and bare metal completely exposed. Trust in autonomous AI is engineered, not granted. Guaranteeing that trust requires absolute, uncompromising control over both the machine and its mind.